Next, I'll cover several different ways to update elements in a Scala vector. And then just as a reminder, because vector is immutable, you don't actually add elements to it or change elements in it. What you do is you add or change elements as you assign the results to a new vector. So in all these examples, remember that you need to do that. You need to assign the results to a new vector. And the next thing I show is this table that shows methods that we use to append and prepend elements to a vector. And so you see the method names over here, the colon plus, plus plus, plus colon, and plus plus colon, for again, for appending and prepending. And what I could do, a good way to show these is to go over, copy that, then we'll go back over to the REPL. Let me move that up here so we can see both at the same time. Clear that, paste that. So that creates a new vector named V1 with those elements 4 through 6. And the first thing I do, the first example, shows how to append an element to the end of the vector, a single element, to be clear, to the end of the vector. So that does a colon plus the number 7. And the importance of that equal sign there. So that appends a single element to a vector. And then to append multiple elements, sorry, it'd be easier if I just type this over. Val V3 equals V2 plus plus. So we use plus plus to add another sequence. So this could be a seq like that, or it could be a list. So I'll just do a list. And what did I do there? 8 and 9. So that creates the vector V3 with those elements appended to the end. And then if you want to prepend elements, what you do is val V4 equals, do the number 3, prepend the number 3, plus colon to the vector V3. And then you see here that gives us the value right there. The new 3 has been prepended. And then when you want to prepend multiple elements, val V5 equals what you want to prepend. So I will say again a sequence here, and this will be 1 and 2. And I'm going to prepend those to V4. And that gives us the new vector. And now a key about this, if you're looking at these names and you're thinking, well, these names are kind of unusual with the colon and the plus and so on. Mostly with that colon character, I guess, is what I'm talking about. And I explained that in this section here, is that one way to think about this is that the colon character in all these examples is always next to the original sequence. So when you're appending, you notice that it's colon plus here, and the colon is closest to here. And similarly, when you're doing the prepending, the colon here is next to the old sequence or the old vector, and the same thing here, colon and the old vector. And so the way this works is that the colon character makes a method right associative. So that means that the method comes from the variable that's on the right side of the expression. And now here things get really interesting, because as we're in this update section of, the CRUD acronym, we're doing the update part here. Update is really a little bit of a vague and nebulous term when it comes to an immutable data structure. So pretty much all these methods that follow could be considered update methods, but I'm just going to show some that are most interesting. Map I've mentioned before, and so we use that to transform an existing vector into a new one. So I show that here where I start with a vector of 1, 2, 1, 2. And so here in this algorithm, I double each element, and then that gives us the vector 2, 4, 2, 4 over here. So that's map. And the other one I want to talk about is updated. And of course, just from its name, you can tell that's an important method when we're talking about updating Scala vectors. So the way this works is you can actually update elements at an existing index with a new value. And I show how to do that here as well. So I'm updating the 0th element to be 100, and then you can see that in the result over here. And I'll let you look over the rest of these examples. I'm just trying to point out some of the most important ones. And we'll see more as we scroll through all of the following methods. Delete is the next section in our CRUD acronym. So I want to show methods for how to remove elements from a vector. And again, there's somewhat of a fine line between what it means to update and what it means to delete when you're working with an immutable sequence. The first thing I do is I show this table which describes many of the methods that you could use to remove elements from a vector. So you can read those descriptions at your leisure. But if I scroll down here, then I actually show examples of how to use all these. So we start with this initial vector here, the vector A, and then all these methods apply to vector A, and then this is the result of each method call. First one here shows the distinct elements remaining in the vector. In this one, I'm calling drop 2, which means drop the first 2 elements, so that yields the last 3 elements in the initial vector. Then drop right works the same as drop, except you drop the elements from the right, so we're dropping 40 and 10 and leaving the first 3 elements. Drop while is a function that says, give me your algorithm and I will drop elements while this condition is true, and then once it's no longer true, I'll return all the remaining elements. So this one drops elements that are less than 25, which are this one and this one, and then it returns the remaining elements, 34 and 10. The filter method takes your algorithm and filters out the initial results. So this one says retain all elements that are less than 25. So then we get 10, 20, and 10, which we get from that initial vector. This one says retain all elements greater than 100, and that returns an empty vector. And I point that out just to show that it's not a null value. So I'll let you look at the rest of these methods at your leisure. One important thing to say is that these are just some of the most commonly used methods, which is why I list them here. So now we're through the CRUD portion of the acronym, which covered the create, read, update, and delete. And now I'm going to look at other methods that are available on Scala collections. And remember that there's over 100 methods, so there really are quite a few. I'm not going to discuss all these in detail, but I just want to show that these are methods that you can use on Scala collections to transform the given collection into a new collection. In this table, I describe those methods. And then if we scroll down, you'll see examples of all these methods. You can see the common examples here. So we have a vector named fruits, which contains those 2 fruits, and then I call map on it. So again, map is very commonly used and yields that result. Sorting is something you're going to want to know about. So this shows a couple of examples of how to sort vectors. And down here, zip is an interesting method where if you have a couple of vectors, you can zip them together. And as you can see, what I've done is I start with women and men, and then I zip those together, and we get these couples. And then we have Wilma and Fred here, and Betty and Barney. So this, remember, anytime you see these guys here, these parentheses, that's a tuple right there. It's a 2-element tuple. So this is a vector that contains 2-element tuples. In addition to those transformational methods, there are many what I categorize as information and mathematical methods available on a vector as well. So as usual, I start with this table that describes all of these methods. And as you can see, there are quite a few. And then when you come down to this next section, you'll see many, many, many examples of all these methods. So I start with sample data up here. Those are 7 sample collections that I'll use down here later. And now you can see how these informational methods work. So you can ask, does this vector of evens contain the number 2? And that's true. Do the first 10 numbers contain this slice, which is an interesting method? And that's true. So contains is a method you'll use a lot. Count is another one that tends to be popular. Exists, find. Really, quite a few of these methods are used often in statistics. So I'm not going to get into all these. I just want to show that there are examples of all these out here. And in this next section, I show index of and last index of. So many examples of how those work, including these slice methods here and these where methods here. And as you can see, the list goes on and on for informational and mathematical methods. In this next section, I was going to discuss fold and reduce here, but I want to cover that in a separate lesson. So for now, the only things I want to say is that fold and reduce let you march over all the elements in a sequence and perform operations on those elements to return a single value in the end, as shown in these examples. So lastly on this page, it's been a long page. There's over 170 examples. And this last section here is about grouping methods. And what I mean by grouping is that they let you create groups from an existing collection. So I do the usual thing. I describe them in the table here. And then I show them in the examples down here. So you see, first we start with this vector here that contains the numbers 1 through 10, which you can see if I scroll right here, 1 through 10. There at the top. Group by, you pass in a predicate. So this is an expression that returns true or false. and has a really interesting result. So it creates a map over here, and the map contains two key values, false and true. So this first one maps to all the values that were false for this expression, so greater than or equal, greater than 5. So these are all the values that were false right here, and then these are all the values that were true over here. So it's really interesting that it creates this map, and it has these two keys, false and true, so you can sort out those values. The group method, here I show a couple of examples, so passing in number 2 and passing in number 5, so you can see that it groups here 2 elements at a time, and then here 5 elements at a time. So it creates all these different groups based on the value that you supply it. And again, that's all coming from that initial vector. The partition lets you break your initial collection into 2 different partitions based on your algorithm. So here I say where all characters are less than a C, and it creates this tuple of 2. Both of these should be enclosed in double quotes over here. So it creates this tuple. So these are the elements that are less than C, and these are all the other elements from this initial string. And then if it doesn't make sense working with characters, here I show another example where I partition, take the first 10 values and partition using this, where current element is greater than 5. So that creates, again, 2 partitions, this vector here and this vector over here. In this next section here, sliding is a method that groups the elements into what it calls fixed size blocks by passing a sliding window over your collection, and it uses a size I and then a step S to step over them. So you're saying I want a size of 2 elements here, so you get 1, 2, then 2, 3, 3, 4, and so on. And then the next interesting part here is you give it a step, and these next 3 examples show what that step size does to your results. So it doesn't affect the first vector inside this vector, because the size is always 2 in all of these examples. So the first one is always 2 elements, but then the step is where it gets interesting. So this has a step size. This first one does not specify a step size, so it goes 1, 2, 2, 3. This one has a step size of 2, so it goes 1, 2, 3, 4. So the step size matches the size of the window, so you get that desired result. And then you have 3 in this case and 4 in this case. And you can see what it's doing is it's increasing this initial value here. And then if you keep going over, you would see that effect going on through the rest of the values. So I think the most common examples are this first one here, where you just specify a size, and then this one where you're here, where you specify a size and a step that matches the size. And then there's a few more examples down here as well. And as a little summary, I just want to share again that this is a page from my website where I share these 170 plus vector examples. As a brief aside, I'm going to go ahead and show what that means for a method to be right associative. And to do that, I'm going to create a little class here. So I'll create a class called col, which is short for collection. I'm going to import an array buffer because I'm going to use that here. So I'm going to create a field. I'll call it AB. So this is a field inside of our class. And I'm going to initially populate the array buffer with the integer value 1. And then what I'm going to do is create our right associative method. So that one I'm going to call plus and then colon. So that's actually the method name right there, plus colon. And I'm giving it a space there just to, actually I can take that away. And just make this more of a method like you're used to seeing. And I'll just say that this is a method that takes an integer value, and I'll call that parameter I. It's going to return unit, which means it returns nothing, because all I'm going to do is add that value I to the existing array buffer field AB. And I do that like that. And then so we can see what's going on, I'm going to override the toString method. And we'll just say, for that one, I'm going to just say AB, which is our array buffer. I'm going to convert that to a string using the makeString method. And what you can do with this is put a comma here, and that will separate each value in the array buffer with a comma. And you'll see how that works in just a moment. So that works, and now I can create an instance of our class like that. And this output right away here, this 1, comes from this toString method. And that's because I've initially populated the array buffer with a 1 right there. And then again, that output comes from toString. And now to show how the right associative method works, the first thing I'm going to do is show how it fails. So I'm going to say C, and I'm going to call that method. So I'm going to call plus colon, and let's try to add 2 to our collection. And you'll see that it fails. And then it shows right here that the method plus colon is not a member of the int class. So what the compiler is doing is it's saying, you've specified a right associative method right here because that one ends with a colon. So the compiler is looking at the 2 and saying, oh, you must have a method named plus colon. But of course it doesn't, so that fails. And then the way to fix this is to use it the way it's intended. So I would say 2 plus colon C. And now that works. And the reason that works is because this method is named plus colon, and the trailing colon right there makes this method right associative. And right associative means that the method is expected to come from the variable that's on the right side of the expression. So in this case, the method plus colon does come from C, which is a collection, and we define the method right there. So that works. And we can see the contents of C just by doing that. And now you see that it contains 1 and 2 as expected. So that's how a right associative method works.